Lesson here is for lesson 14 and 15. We're combining them. I don't think you'll have any trouble combining those as it's just going to go over elimination today. We've done substitution already. Today I'm going to show you how to do elimination. So this is lesson 14 and 15, and we're going to follow along with the Desmos that's attached to the lesson. Okay, so first what we're going to do is we're going to review a problem that we think substitution would be best to use. So whenever you see a problem like this and I identify, hey, this problem right here, that is, I have it solved for a variable, we can see that it really is pretty much in slope-intercept form. We're going to take that, and I'm going to take that 20x plus 2, and I'm going to substitute that in for the y. So my new equation after I do that is 5x plus, and remember, we're going to always put what we substitute in parentheses. So I'm going to have 20x plus 2 equals 7. Again, I substituted in what was for y and for 7. And so since there is nothing there, it's just 5x plus 20x plus 2 equals 7. Okay? Now, I'm going to combine my like terms, the 20 and the 5. So I do get 25x plus 2 equals 7. Move your 2 over to isolate the variable, and I do get 25x equals 5. Okay? Are we all good so far? Hopefully you are. If I'm going too fast for you, make sure that you're pausing and you're rewinding. Divide by 25. Divide by 25. And x, guys, is going to equal 1/5. 1/5. Okay? So now that we know our x value, we can plug that in here or here and solve for it. Let's go ahead and plug it into the bottom one. So hey, let's say this. 20, insert that x, 1/5 plus 2 equals y. Well, what is 1/5 of 20? Okay, in other words, what goes into 120? 5 times. It's a 4. So 4 plus 2 equals y. So 6 is what y equals. Remember, we do need to put that in a coordinate point as the answer because it is a point on the line where they pass. So my answer is 1/5, 6. Remember, we list it as an ordered pair, and the x comes before the y. Okay? So 1/5. And oh, make sure that you're hitting the right button, and then that will get that through there. I explain those steps as we go. All right, so now let's take a look at this, okay? Write 2 things that you notice about the hanging diagrams. Write at least one question that you have about the hanging diagram. So we can see that, we've got some pentagons, we've got some squares, we've got some triangles, we've got some circles. One thing that I notice right off the bat here is that, let's see, 2 circles. Okay, 2 circles equals a square, right? Okay. And 1 circle, 1 triangle equals a pentagon. Okay, so that's one thing that we notice. All right. And then write at least one question that you have about the hanging diagrams. How about what exactly are they referring to here? And so now, what do you notice about the left side of the last hanger? Well, I can see here, hey, I've got the left side of this is 2 circles. Here is a circle and a triangle, and then this one is 3 circles and a triangle. So it looks like they just added them together. So I have on the left side of the last hanger, it is the previous 2 hangers added together. Okay, fair enough. What do you notice about the right side of the hanger? Hey, same scenario, right? Same scenario. I look here and I've got a square, pentagon, square, pentagon. So they added them up. If we only saw the first 2 hangers but knew that the third hanger had the combined weights from the corresponding side of the 2 hangers, could we predict whether the weight of the third hanger would balance? Yes. Yes, if they're balanced on the left side and if they're balanced on the other 2, if we're combining, they still would be balanced. All right, because you're adding them together. That means that it's still balanced. Okay? Now, let's looky here, okay? What did Diego do to solve the system? Well, I look here, okay? Here's his system of equations. And what I see here is here's his work. It looks like he took both equations, guys, and just added down. Notice how he said his 4x's canceled out. His 3y and his 5y equaled 8. And he went like this and solved for y. Then he plugged y into the top equation and solved for x. Okay, so it looks like here he added down to solve for y, then plugged y in to solve for x. Is that a pair of the solution? We could see, okay, he found that 1 and 2 was it. So, hey, the one way you can check your answers, remember, is you plug it in. So we see, let's look, 4 times 1 plus 3 times 2, does that equal 10? Well, 4 times 1 is 4, plus 6 equals 10. Yeah, 10 equals 10. Works for the top one. Let's check the bottom one. Negative 4 times 1 plus, what do we have? 5. Oh, yep, 5 times 2. Does that equal 6? Negative 4 plus 10 equals 6. 6 equals 6. So yes, what he did is a solution. How do we know? We check the solution by plugging it into both equations. Does his method, adding, work for solving this system? Well, let's write it down and see, okay? Hey, if you're following along and you're not writing things down, you're doing yourself a disservice. Make sure that you have pencil and paper, and then when we do anything math related like this, you're writing it down too and you're solving it. It's good practice for you, okay? Let's look. Here's the equation. Like I said, today we're going to use adding and subtracting equations to see the systems of equations to see if we have solutions. So let's add straight down. Well, I've got 2x's, another x. That's going to give me 3x. Boy, howdy, looky here. My y's cancel out. And then I have 4 plus 11. That's going to give me 15. All right. Divide by 3. And we see that x is going to give us 5. Now, I'm not done. Okay, I've got to take that 5. I've got to plug it into one of my equations. I can either plug it into here or I can plug it into here. For my case, let's plug it into, let's just do the top one. All right, so I got a 2 times a 5 plus y equals 4. 2 times 5 is 10 plus y equals 4. Move the 10 over. All right, and y is going to equal 4 minus 10. That gives me a negative 6. Now, do not stop here. Make it as a coordinate point to make yourself look like a smart individual. And then the 5, negative 6 would work. So yes, it would work because the y's would cancel out. Okay. Now what about here? Would adding work here? The answer is no. No. Because no variable would cancel out. Okay, the whole point of elimination is I'm eliminating a variable. Notice here my 8's aren't going to eliminate. My y's aren't going to eliminate. Don't want to do that. Okay, so no, it wouldn't work. All right, now why does adding the equations work for solving the system up top, but doesn't work for the system down below? All right, I can tell you right now. The first system would have a variable cancel out, which is what we want. That way we can solve for the other one. Second, would not, all right, would not have a variable that cancels out. Okay? Hopefully, yep. All right. Now, here's the kicker. So we just did addition. What about subtraction? Would subtraction help us in solving this system? Yes, yes, yes. Okay, yes, yes, yes. So, let's do it. All right, so here we go. Okay, 8x plus 11y equals 37. 8x plus y equals 7. Okay, now, hey, just like adding down, guys, it's the same thing, but I'm going to manipulate this so that I can get them to cancel out. And remember, we can do this because if I add something to one side of the equation, I only have to add it on the other side. So I'm not physically changing. This is still at the end of the day, the variables will still be the same, but as long as I do it to the left side of the equation and do it to the right side of the equation the same amount, I'm okay. So what we're going to do is we're going to change the signs on the bottom equation, and notice I changed all three of them. We have to change every single sign because now look what happens. Our x's cancel. All right, we did it. Now 11 minus 1 gives me 10y. 37 minus 7 gives me 30, which is great for us because now when I divide by 10, y is going to equal 3. All right, now we got to plug it into an equation. Let's plug it into the bottom original equation because that's going to be the quickest, okay? 8x plus, we know that y is 3, and that's going to equal 7. Okay, 7. So now when I subtract 3, I'm going to get 4. So 8x equals 4. Divide by 8. And x is going to equal 4 over 8, or we know that to be 1/2. So then my answer is 1/2, 3. Okay? All right. Here's a system of linear equations. Would it be more helpful to solving it? Adding or subtracting? Let's look. Are my signs already different? And if I added down, would they eliminate? Yes. Okay, I'm going to add down. Why would it be more helpful? Because they would already eliminate if I added. Okay. Solve it without graphing. You got it. Okay. Let's get a new sheet of paper here. Okay. So 2x plus 1/2 y equals 7. 6x minus 1/2 y equals 5. We said we were going to use addition. Okay, we said we were going to use addition because these already cancel, so they cancel out. 2 plus 6 gives me 8x. 7 plus 5 gives me a 12. Okay, divide by 8, divide by 8. 12 over 8. Okay, what's that going to give me? Well, we know that, hey, what goes into it? 4 3/2. So x is going to equal 3/2. Let's plug it into the top equation to get our answer. So now I'm going to have 2 times 3/2 plus 1/2 y equals 7. 2 times 3/2 is a 3 plus 1/2 y equals 7. Move your 3. Okay, so now I'm going to have 1/2 y equals 4. Divide by 1/2. Divide by 1/2. Y is going to equal 8. 8. Because when we do this, we're going to flip and multiply. So I'm going to have 4 over 1 times 2 over 1, 8 over 1. So y is 8. So that means my answer is 3/2, 8. We write it as an ordered pair. Okay, and we're good to go. All right, now guys, a teacher has purchased 20 calculators and 10 measuring tapes for her class and paid $495. Later, she realized that she didn't order enough supplies. She placed another order of 8 on the same calculators and 1 more on the same measuring tapes and paid $178.50. Here's a system that represents the constraints. In this situation, what do the solutions to the first equation mean? Okay, what's the solution mean? Guys, first off, we know that the solution is xy, and so just ask yourself, hey, xy, what does it mean? X is going to be the price of what? She bought 20 calculators, so the price of calculators, and then y is going to be the price of measuring tapes. Okay? Now, when we see here, what's the solution to the second one be? All right? Hey, still the same. Okay? We're still doing x, y as my restraints. Okay? So that means that, again, it's the price of calculators and the price of measuring tapes. How many possible solutions are there for the first equation? Okay. Hey, it's one line, and so that we have this, and if it's just for the solutions, okay, remember it's anything on that line. So it is infinite. Infinite because it's anything that's going to be on that line. All right, that line, all right, is going to look kind of like this. If we drew that, here would be my line. And so it's anything on that line as long as their whole numbers are possible solutions. Go to number 17. So now, guys, if I'm finding a situation, where does the system mean? In this situation, what does the solution of the system mean? That's going to give us the price of calculators and the price of measuring tape, since, I mean, that's already what the solution is to both of them. It's not going to change once I actually bring them in. So here's the both equations, guys. We're going to find the solution. So we click on it. We see here that x is 21.5 and y is 6.5. It's where they cross. Oh, to hit that. There we go. So that means that's where it's crossing. That is the answer to my solution, or to my system. Okay, now it says here, to be reimbursed for the supplies, this items purchased 28 calculators and 11 measuring tapes for the amount of $673.50. Write an equation to represent the relationship now with the total amount spent. So, using the same variables, guys, we would see here. She bought 28 calculators plus the 11 measuring tapes, and that total is going to be $673.50. Okay, and there is my green line. All right. How is this equation related to the first two equations? Well, that is simple, guys. Okay, it still is giving, it's still finding the price of calculators and measuring tapes, and still there's going to be one solution to the system, even though we have another equation. There's still only going to be one solution. Okay. Oh, right there. What does the solution again mean? Okay, it is the price. It's the price. Were you able to solve it by adding or subtracting the equations without graphing? So we do look here. Here's my equation. Would any of these cancel if I added down or if I changed signs and subtracted? The answer? No. No, it would not work, okay, because a variable wouldn't cancel. Perfect. Perfect, perfect. Okay, guys, here we go. Let's solve these. Remember, it's going to be in an ordered pair. Okay, we do have 2x plus 3y equals 7. I've got a negative 2x plus 4y equals 14. A little bit really close in on my hand. I'm going to back up a little bit. Now, would I add or subtract these? Do they cancel when I already go down? The answer, yes. They already cancel, so I can leave the signs the same. Now I've got a 3 and a 4, and that's going to give me a 7y. I got a 7 and a 14, that's going to give me a 21. Divide by 7, and y is going to equal 3. Now, guys, we take that 3 and we plug it into either the top or the bottom equation. I'm going to plug it into the top equation. So now I have 2x plus 3. Plug in your 3, and my answer is 7. Okay? So now I have 2x plus 3 times 3 is 9 equals 7. Move your 9 over to isolate the variable, and I get 2x equals negative 2. Divide by 2, x is going to equal negative 1. We write that as an ordered pair. Okay, so my answer, guys, is going to be negative 1, 3. All right. Let's look at this next one here. Okay, so now, guys, we still have 2x plus 3y equals 7. However, now we have 3x minus 3y equals 3. Okay, if I add down, does it work? Yes. Let's add down. Middle cancels. 2 and a 3, give me a 5x. 7 and a 3, give me a 10. Divide by 5, x equals 2. Okay, let's go ahead and plug it into the top equation. That one seems pretty easy. So we have 2. I'm putting my 2 that I found into the equation for x plus 3y equals 7. 2 and 2 give me 4 plus 3y equals 7. Move the 4 over to isolate the variable, and I get 3y equals 3. Divide by 3 to isolate the variable, and I get y equals 1. Now, I see here, guys, my ordered pair is 2, 1. If I wanted to see I did that answer, I'm on the test, and I'm like, I do not want to miss any points. I want to make sure that's correct. There is no flame emoji on the test. How do I figure that out? Okay, you can plug it in to these equations. If I plugged a 2 in for x and a 1 in for y, I would get 7. If I plugged a 1 in for x here, I plugged a 2 in for this x, I plugged a 1 in for this y, I would get 3. Okay, it would work on both equations. Now, here we go. I've got a 2x plus 3y equals 5, and a 2x plus 4y equals 9. Now, wouldn't want to use substitution on it because, hey, there's no y equals, okay? And we have things that are going to easily eliminate. So I look at this. If I add it down, I would get a 4. I wouldn't eliminate. So I need to change signs. I'm going to need to use substitution and subtract it. So remember, when we subtract, we're really saying change signs, add down. Cancel. 3 minus 4 now is just negative y. 5 minus 9 is negative 4. A negative y means it's basically negative 1y, so I'm going to divide by negative 1. Y equals 4. All right, let's plug it in the top equation. 2x plus 3 times 4 equals 5. That means that's 2x plus 3 times 4, which is 12, equals 5. Subtract 12. Oh, we'll see if we get this right. I'm going to divide by 2. I get x equals negative 7 halves. All right, let's see if we did this correct. And we did. Don't be afraid. Don't be afraid of fractions. Okay, don't be afraid of fractions. Okay, was it okay to add an expression 2x plus y to one side of the first equation, but add a 7 to the other side? Okay, meaning we were adding this to this side to get the x's to cancel out this to this. And guys, the reason is because of right here. It tells us an equal. And you would say yes, because they are equivalent expressions. Okay. Why does the new equation still give the same solution even though we didn't add numbers or expressions from the same side of each equation? It's because, guys, we're using, again, equivalent equations. As long as 2x plus y equals 7, you can add the 2x plus y on one side, the 7 on the other, and you would still get your normal answer. Okay, some of the family members would like to see a second serving, I'm sorry. So we went back to the same food stand and bought another 2 cups of hot cocoa and let's start over. I was down here. On a family outing, Tyler bought 5 cups of hot cocoa and 4 pretzels at $18.40. Some of his family members would like a second serving, so they went back to the same food stand and bought another 2 cups of hot cocoa and 4 pretzels for $11.20. Here is a system of equations that represent the quantities and constraints of this. What does the solution mean, or to the solution to the system, CP, represent in this situation? Well, guys, think about it. What would you take 5 times and what would you take 4 times to get 1840? They're talking about money. So in this scenario, guys, the C, what's the C stand for? The cost of hot cocoa. What's the P stand for? The cost of pretzels. All right, fair enough. If we added the second equation to the first equation, we'd have a new equation, 7C plus 8P equals 2960. Explain why the same pair is a solution to the 2 original equations is also a solution to the new equation. Guys, all it does is it gives us, because we're still adding equivalent expressions to both sides. Okay, still equal. Does it really help us? I'm going to say no, okay, because, hey, now that I know that I added them, it's still giving me that scenario, okay? What I should have done and what would have helped us is if we would have subtracted equation 1 from equation 2. Okay, if I would have done that, then, guys, I would have found out the price of hot cocoa and the price of the pretzels. All right, with that, hey, thank you for tuning in. You've got your classwork now. If you have any questions, please reach out to your teacher. And then also, hey, don't forget the math help that's offered 4 to 5 every day in the Student Success Center and 8 to 9 in your house Sunday through Thursday on the Zoom links. So with that, have a great day. I'll see everyone tomorrow.